Hi folks, so this is our second video lesson. It's also going to be the last lesson that we're filming in our familiar classroom. The rest of these lessons are going to be filmed at home as we all practice social distancing. So you get to see a little bit of my home office. That might be cool or you might hate it. Either way, it's what it's going to be. Today we're going to talk about equations of a circle and rearranging them. It's going to be using some stuff from previous math classes. In Algebra 1 and potentially Algebra 2, you saw this as perfect square trinomials. We're going to see it today with rearranging equations of circles. So today, folks, our aim is how do we rearrange the equation of a circle? And the big idea today is we'll have two forms of the equation of a circle. We're going to take it from one form into the other. Now, this is the form of the circle that we've been working with so far. It's nice, it's easy. I can easily tell here that my center is A comma B, and I easily know that my radius is R. So this would be my center, and my radius would just be a length of R. And we've seen that this is a really nice equation to work with. This is a bit messier. What we're going to have to do here is rearrange all of this so we have x and a constant in parentheses squared. We have y and a constant in parentheses squared. And we have our radius over on one side. In order to do that, we're going to use a perfect square trinomial. Now, a perfect square trinomial you may have seen before in Algebra 1 or Algebra 2. It's a trinomial where you have something by itself squared, a binomial squared, and it equals a trinomial. And the nice thing is, whatever this number is, you're just going to double it for the middle term. You're going to square it for the last. Now, this looks confusing. We're going to walk through one example together. I promise its bark is much worse than its bite. So let's take a look at this one. We're finding the center and the radius of a circle described by this, quite frankly, awful-looking equation. We have a ton of stuff here. We have a ton of stuff here. It equals 36. It looks bad. The nice thing is all of this uses perfect square trinomials. This is going to be one perfect square trinomial, and then we're going to have a second perfect square trinomial here. How can I tell these are perfect square trinomials? Well, if I look right here, half of 6 is 3, 3 squared is 9. If I look right here, half of 4 is 2, 2 squared is 4. I can rewrite these things out now. I can say that this is going to be x plus 2 quantity squared. Have my little plus sign in the middle. I know that this is going to be y minus 3 quantity squared. I know this is a minus because that was a negative 6. I know this is a plus because that was a positive 4. This is always going to be positive, and this is always going to be positive. Now, what does it equal? Well, we know to make it look like our nice version, we need it equals r squared. Well, that's a perfect square. It's 6 squared. So that means my center here is just going to be negative 2 comma 3. Notice again, I switched the sign here. I switched the sign here. And my radius is equal to 6. And I'm done. So we have a second example here. We're still finding the center and the radius of the circle described by the following equation. This one isn't as nice, unfortunately, because this, everything with the x's, that's not a perfect square trinomial. In fact, it doesn't even have a third term. It can't be a trinomial. Same thing with my y's. This, not a trinomial. And it's equal to a rather large constant. Let's take a look and see what we can do. We know that a perfect square trinomial is half of this number squared. So, off to the side here, I'm going to do 4 divided by 2. I'm going to square it. Well, 4 divided by 2 is just 2. Keep the square, and that's just going to be 4. So I'm going to add everything in, like such. X squared plus 4x, and then I'm going to add in this little 4 that I figured would help. And now, this is a perfect square trinomial. I'm going to do the same thing with y. I take half of this negative 12, I'm going to square it. Now here's why that's always going to be a positive, that square term. Because I'm going to do negative 12 divided by 2 squared. Well, that's going to be negative 6 squared. But negative 6 times negative 6 is positive 36. Squared, Gallagher, not cubed. So I can rewrite my trinomial like this. Bring down the y squared, bring down the negative 12y, and add this 36. Now, I have 156 over here. And we know that it's a rule of algebra, if I do something to one side, I have to do it to the other. So just like I added a 4 here, I'm going to have to add a 4 here. Plus 4. And just like I added a 36 here, I need to add a 36 here. Plus 36. Well, let's simplify a couple of things here. If I add together the 156 and the 4, I get 160. I add the 36 to that, I get 196. Cool. Looking better already. And then I can take a look at this part. Because I added the 4, now it's a perfect square trinomial. I can rewrite it as x plus half the middle number. X plus 2 squared plus y half the middle number, so minus 6 squared. You'll notice that the number that's here is going to be the exact same number we're squaring up here. The number that's here is the exact same number we're squaring up here. Well, 196, that's a really nice number to square, or rather take the square root of, because it's just 14 squared. Here's where those square roots came in handy. So we're asked to find the center and the radius. The center is going to be flip this, flip that. So negative 2, comma, positive 6. My radius is what's being squared there. So it's just 14. And we're done. So that was our first example. Now we're going to take a look more at an example that's a bit more complicated looking. You need to use a bit more algebra to move things around. But it's still that same idea. We still want to manipulate the equation so that it has perfect square trinomials, because we can change perfect square trinomials into the equation of a circle pretty easily. So, as we can see here, we have a third example, really similar setup to the previous two. We're finding the center and the radius of the circle described by this equation. This equation has no constants over here. Every term has a variable, and it just has a 0 over here. Even though it's 0, we do the exact same thing. I'm going to start with my x's. I'm going to take half of this term and square it. By the way, if you want to try this on your own, pause the video and give it a shot. So I'm going to take negative 6 over 2 squared. That's going to be negative 3 squared. Remember, this is going to end up in our equation, the negative 3. And then that's going to be 9. So that means that this is going to be x squared minus 6x plus 9. This is always positive. When I take a look over here, I have my y squared minus 8y. So I'm going to have my minus 8 over 2 squared. Well, that means I have negative 4 squared, and that's positive 16. Well, that's going to mean that I have plus, I want to keep it in the right color, y squared minus 8y plus 16. Well, I did it to one side, I got to do it to the other. So I'm going to add 9 to the 0. I'm going to add 16 to the 0. Again, I'm doing it because I added a 9 here. I have to keep my equation balanced. I added a 16 here. I got to keep my equation balanced. Luckily, this adds together to just be 25. This is now a perfect square trinomial. That was our goal. We manipulated it to be a perfect square trinomial. I take x plus or minus half of this. Remember, it's that same, the negative 3. So here I get x minus 3 quantity squared. Well, plus in between. I take a look at this. It's going to be y. Take the negative 4, because the negative 4 is half the negative 8. Quantity squared. Then it equals, here's where the 25 comes in. That 25 is going to be my squared radius. Square root of that is 5. Well, that means that my center, I flip that sign, so it's positive 3. I flip that sign, so it's positive 4. My radius is 5. And we're done. So you just saw 3 examples of how to rearrange the equation of a circle to find the center and the radius. That's what you're going to do now for Delta Math. Because we only had 1 video today, you're going to do 10 problems. Again, there's no penalty. You're just going to find the equation and then find the center and the radius from it. Do it in your notebook. If you're having difficulty getting to those 10 problems and finishing them all correctly, take a picture of your notebook, send it to me, or talk to me during office hours, and I'll be glad to help you. Other than that, after you finish the Delta Math, complete the summary, and you're done with our second mini lesson. I'll see you again in my home office. Hope everyone is safe, and I'll talk to you again soon. Bye-bye.